So in this problem, we need to determine the sum to n terms of the following series. Okay, let us begin. So here we have a series with first term being 3, followed by 18. Then we have the next term, which is 57. Next, we have 132. And then we have 255. And we have the rest of the terms. Now, clearly, this is not an arithmetic series because there is no common difference. And also, it's not a geometric series because it does not have any common ratio. But what we can do here, we can find a pattern to find out the nth term of the series, and I'm going to denote that nth term as Tn. So let's say we suppose this series is denoted by Sn, where Sn represents the sum to n terms and Tn represents the last term or the nth term of the series. Okay, now here what we'll do, we can rewrite the first term 3 as 1 added to 2. So this is going to be the first term. Then 18 can be expressed as 2 added to 16. Okay, then we have 57 that can be expressed as 3 added to 54. Next we have 132, so that will become 4 added to 128 added to 255. So 255 will be 5 added to 250, and we have the remaining terms. Next, what we'll do, we'll again rewrite the second term to 1654 of each of the terms. So here we have 1 added to, now 2 can be expressed as 2 times 1 added to 2 plus 16, but 16 we can write it as a factor of 2 as 2 multiplied to 8 added to, we have 3 plus 2 multiplied to 27. Then we have 4 added to 2 times 64 added to 5 added to 2 times 125. Okay, then we have the rest of the terms. Now again we're going to rewrite each of the terms. So our first term will be 1 plus 2 times, we have 1 here, but we're going to express it as 1 cube. It will become evident in a moment. Next we have 2 plus 2 times 8, but this 8 can be expressed as 2 cubed added to, next we have 3 plus 2 times 27, 27 can be expressed as 3 cubed added to 4 plus 2 times 4 cube. So you can observe that there is a pattern arising here. So we have the term 5 plus 2 times 5 raised to the power of 3. So if we continue like this, then we can easily define the nth term. So that is going to be n added to 2 times n cube. So this is going to be the nth term of the series. So here we have found out that, so here we have obtained Tn equals to n added to 2 times n cube. So now that we have the nth term, we can easily define the sum up to n terms. So now the sum up to n terms of the series, this is simply defined as take the summation of the nth term of the series. But what we'll do, we'll change the index from n to k such that the summation, because we're summing over k, so the k runs from 1 to n. In other words, what we need to do is find out the summation of k plus 2k cubed, where k runs from 1 to n. Okay, now let's try to find out the sum. So this is simply going to be equals to summation of k, where the index k runs from 1 to n, added to 2 being a constant, we can pull it out of the summation. So we have 2 multiplied to k cube with k running from 1 to n. Okay, now what is summation of k? So summation of k, that's simply 1 plus 2 all the way up to n. This is summing up of the first n natural numbers, and then we have 2 multiplied to summation of k cube. So that means we are adding the cubes of the first n natural numbers. Now we have a formula for each of them. Now the sum of the first n natural numbers, that's given by n times n plus 1 divided by 2 added to 2 times. Now sum of the cubes of the first n natural number, that's given by n squared times n plus 1 whole squared divided by 4. Fine. So now we have n times n plus 1 divided by 2 added to n squared times n plus 1 whole squared divided by 2. We can combine the two terms to obtain the final sum. So let's take n times n plus 1 over 2 as the common factor. That means from the first term we'll be left with 1, and from the second term we'll be left with n times n plus 1. Okay, so now we can combine them to get n times n plus 1 multiplied to n squared plus n plus 1 whole divided by 2, and this is going to be our final sum to n terms of the series, which is given by 3 plus 18 plus 57 plus 132 plus 255 and the rest of the terms.